And so this I don't think we've solved together yet. Maybe in the first homework or something when you had a bunch of differentials to solve, you looked at something like this. But we can solve this using the product rule. So the product rule is going to say we can take the first derivative of this with whatever we're taking the derivative with outside here. So we can take basically dr times dt dr. Then we can take the differential of the second term and multiply by r. So what we'll end up with anyhow is going to be dt dr times dr dr. 1 plus, now we'll have r d squared t dr squared. Equals to 0. Okay. And so this is just 1. We have d squared t dr squared. Let's see, do I want to move that on the other side of the equation? Nah. And I've just written it in a slightly different form, 1 over r dt dr. We divided everything by r. All right, so this is the differential that we'll need to start solving. To do this, we're going to make a substitution. We are going to substitute, we need to pick a kind of dummy variable. We could have u equals dt dr. If we pick u equals dt dr, then we can have d squared dtr is du dr. So we can have 1 over r, basically u over r, plus du dr. If we make a u substitution, then we can rewrite this. This becomes u. This becomes du dr plus u over r equals to 0. All right, and now we have a separable equation. Now we can move this to the right. Negative u over r, so we can have 1 over r, or negative 1 over r dr, and 1 over u du. Sorry, I'm getting a little low on the page here. And we know the solution to these. We have the natural log of u equals the natural log of r plus c. I won't forget my negative of r plus c1. And we need to solve now. I'm getting a little clear here. Now we need to solve this, so we'll take the exponential of each side. E to the ln of u is just going to be u. All right, so we have e to the negative ln of r plus c1. Let's write it. So this is the same as saying e to the negative ln of r and e to the c1. And so what this will become is c1 over r. Maybe a c2 if we say e to the c1 is c2, but it won't matter. Right, because that's a slightly different constant than we started with, but it's not going to make a difference in our solution. All right, so we have u over r equals c1. Let's see where we started with. We need to make a substitution. We let u equal dt dr. So dt dr equals c1 over r. All right, so that means we need to take one more antiderivative. And our temperature profile might look something like C1 natural log of R plus C2.